Hello everybody and welcome to the Fujifilm stand, co-partnered this year with MoSys Engineering from the UK and APG from the USA. With over 80 imaging years of experience, Fujifilm and Fujinon is a well-known worldwide brand. MoSys is a pioneering inventor and manufacturer of virtual production technology solutions, remote production, and image robotics. They're providing the content, the LED content server, and the remote heads for this presentation. APG Media is a supplier of virtual production technologies across North America. They're providing the LED wall and the LED processor for this presentation. Now we've got lots to show you, so we're going to actually split this demo into two parts. Part one, a cinematic focused LED virtual production demonstration. Part two is remote heads and lenses. Let's start with a virtual production. Virtual production has seen incredible growth over the last 2 years. Fueled by a combination of COVID enforced restrictions, a particular film being released, improvements in real-time photorealistic graphics quality, and the adoption of LED technology. So fast has this LED virtual production market grown that we haven't had time to implement the types of standards that are common in other parts of film and television. The color, for workflow, and for image quality. We've also ignored the fact that we've used live event LED walls, live event media servers, and motion capture tracking, none of which were designed for cinematic virtual production. Today, in what MoSys terms Virtual Production 3.0, we're beginning to use purpose-designed cinematic LED tiles with smaller pixel pitches, cinematic LED content servers, dedicated camera tracking, improved imaging standards, and smart workflows that leverage the cloud in collaborative production. With this in mind, let's take a look at our LED virtual production setup. There's essentially 4 key elements to any LED VP stage. The LED wall itself. APG Media has brought along a new 1.5mm LED tile designed specifically for virtual production application. These seamless LED tiles have unique technical properties to produce incredible on-camera performance. An LED processor. We're using a Brompton SX40, one of the leading LED processors for LED virtual production. The LED content server. We're using a MoSys VP Pro XR system. This is the only purpose-designed LED content server on the market today, designed to offer unique cinematic capabilities and created by cinematic professionals with decades of virtual production expertise. And our camera lens tracking. To blend the virtual graphics seamlessly with the real world, we're using a MoSys star tracker, which uses these retroreflective stars that are normally on a studio ceiling or a floor to calculate 6-axis camera tracking. And it combines this with the lens metadata to drive the virtual scene onto the LED wall. The camera we'll be using is Camera 1. It's a Sony Venice cinema camera with a large format Fujinon Premista A 28 to 100 lens. This lens is equipped with extended data, which provides MoSys LED content server with valuable shading and distortion information in real time, along with other metadata such as focus, iris, and focal length. Using a zoom lens as opposed to a prime lens eliminates the need to pause production to recalibrate the lens every time you want to change your focal length. We're going to show you 2 new LED virtual production developments, both geared to cinematic LED virtual production. The MoSys Cinematic XR Focus and the MoSys NearTime Auto Re-rendering. Let's take a look at this first one. We want to pull focus between our talent and the window. Most people don't know that this isn't actually possible. If you try to do this, the virtual scene will simply blur as soon as the focal plane reaches the LED wall. But watch what happens when we do this using a cinematic XR focus. The window becomes into focus as the talent goes out of focus, exactly as the focus puller expects. Cinematic XR focus works with a moving camera, and importantly, the focus puller doesn't have to change the way they work. If you consider where we're going with the digital doubles and the ever greater photorealism in virtual graphics, LED volumes will soon be displaying much more than just a plain backdrop. Cinematic XR focus is unique to MoSys, and it's patent pending. The second new development that we'd like to show you is called NearTime. This won the HPA Engineering Excellence Award at last year's HPA Retreat. Now here's the problem. All virtual production graphics must be optimized in the order that they play back in real time. If the scene can't play back in real time, then you can't shoot in camera VFX. But optimization is essentially reducing the image quality to lower the processing load to increase the playback frame time. Once real-time playback frame time has been achieved, unless the processing overhead allows for higher playback frame rates, the quality of the virtual graphics is fixed. This may work for some virtual scenes, but whenever a highly detailed virtual scene is required, the shot will need to go to post-production compositing. Except that avoiding the need for post-production compositing is one of the key reasons that we're using virtual production in real-time VFX. NearTime is MoSys' solution to this problem. NearTime runs in parallel to the real-time VFX shot. As each real-time VFX shot begins, the camera tracking and the lens data is captured. It's sent to the cloud with the same virtual graphics scene exists on multiple servers. Here, each takes virtual scene is re-rendered, and this time with all the quality dials dialed up. All re-rendered scenes are returned to wherever production wants them automatically and recomposited with the foreground talent. Here you can see the difference between the quality of the real-time composited shot on the left and the near-time re-rendered version on the right. Of course, re-rendering does take longer, but the production still delivers much higher quality content in the same real-time VFX shot delivery window. Re-rendering costs are minimal, whole process automated, and no traditional post-production compositing is used, although it's still available if it's required. NearTime is a patented solution for MoSys. Now, let's take a look at part 2 of our presentation, covering remote heads and lenses. Camera 2. Over here is Sony's new Z750 4K camcorder with a Fujifilm's most popular 2/3 inch broadcast lens, the UA18 by 5.5. It features improved S10 servo. These 16-bit drives are more precise, more responsive, and feature backlash-free performance to meet the demands of the growing robotic camera market. Camera 3 over here. It features a Fujinon UA125 by 8 broadcast lens. The world's highest zoom ratio, 125 times. The UA125 is part of Fujifilm's flagship 4K Plus Premiere series, with optical performance surpassing 4K. It features ARIA, which dynamically adds the precise amount of gain to the camera as the lens ramps to telephoto. It also automatically compensates for corner shading at long focal lengths. Camera 4, over there, that's an Arri Alexa Mini LF mounted on the new MoSys G30 heavy-duty gyro-stabilized head, designed for precision movement with techless operation. It features a Fujinon Cabrio in 19 to 90 millimeters with a Musashi 1.4 times expander, converting the lens to a large format 26 to 126 millimeter zoom. This workhorse Cabrio celebrates 10 years of creativity and innovation. Camera 5 over here. It's a Grass Valley LDK 100. It's mounted on the new MoSys U50 box lens remote head, driven by a 15 by 70 pan bars, which you can see here, to provide the right level of precision movement and inertia feedback. This unique phone has been designed to have the smoothest, most possible precision movement. one has extreme, and even on extreme zoom, this one features a UA 107AF autofocus capability. Compared to past AF systems, Fujifilm's new phase detection technology provides faster, more accurate focus performance with a unique tracking sensitivity that enables the autofocus to retain focus even when obstructions appear in the frame. Another new solution-driven feature showcased on this camera position is Fujifilm's remote back focus. With the camera 12 feet in the air, it would be hard to back focus this lens manually, right? With Fujifilm's new remote back focus technology, an engineer with RCP can easily set the lens's back focus from the truck. The U50 head provides pan and tilt tracking data, combines this lens with zoom data to drive MoSys' VP Pro production software, compositing these AR graphics. These are the same technology set that was used to deliver in this year's Thanksgiving Day parade in New York, except we're using graphics that were generated in Unreal Engine 5. Now, camera 6, Panasonic VariCam, mounted on a MoSys L40 remote head. The L40 is an industry standard remote head for cinematic production. Now, this is used on countless Tier 1 movies. On this camera, we have a Fujinon UA 146 times lens with a Super 35 adapter. This combination lets wildlife, sports, and house of worship camera operators a remarkable 26 to 1100 millimeter focal range. That's the end of our presentation. If you'd like more information on Fujinon lenses, please find one of our Fujinon teams here in the stand. If you'd like to learn more about LED technology or to design and build your own LED stage, please see anyone in the APG shirts. If you'd like to see MoSys' broadcast LED virtual production solutions, head on over to AOTA. Or if you'd like more information on MoSys' LED solutions, reach out to one of our MoSys team members in the black polo shirts. Thank you for joining us.